Another graph interpretation question. This one you're not using a graph to build on an understanding for a problem. In this case, you're using a problem description in order to build a graph. This runner is initially traveling 3 meters per second positive before experiencing a deceleration. Negative 1 meter per second needs to be squared. That's going to bother me. Better. Okay, so we're just going 3 meters per second for the first 3 seconds. Keeping that steady rate of velocity before experiencing a steady deceleration at a rate of negative 1 meter per second. So that just means that we have a line with a slope of negative 1 over 1, which is easy to draw. And alright, so there's our velocity versus time graph. Our position versus time graph, a little bit more complicated. We begin at negative 5 meters at time equals 0. And we experience a constant positive velocity for the first 3 seconds of positive 3 meters per second, which means we end up at position negative 2, and then we end up at position positive 1, and then we end up at position positive 4. So let's see if we can get that diagram for you there. That's pretty good. All right. Now the problem gets a little bit more kind of difficult. Between 3 and 4 seconds, you might ask yourself, what's my velocity? Is it 3 meters per second or is it 2 meters per second? And because it's constantly changing, it's accelerating there, you know, we probably are wondering what number to put. Well, the average velocity that you do between 3 and 4 seconds is actually 2.5. So we'll land on 6.5 there and say, hey, you're going an average velocity of 2.5 seconds there. Okay, trying to land in the middle, 6.5 there. Now again, between 4 and 5 seconds, you're probably wondering, am I going 2 meters per second or am I going 1.5 meter per second or 1 meter per second? Well, you're going 1.5 meters per second because it's the midpoint there. You're going an average velocity between 4 and 5 seconds of about 1.5 meters per second. So if we're leaving at, 6.5 seconds here, that means that we land at essentially 8 seconds there, completing 1.5 meters of motion. And finally, between 5 and 6 seconds, am I motionless or am I going 1 meter per second? Well, you're going 0.5 meters per second. So if we left 8 meters at 5 seconds, we would land on basically 8.5 meters there at 6. So at 6, we're at a position equal to positive 8.5 meters. And you get that representative parabola for your position versus time graph based on what your velocity versus time is doing.